Hi everyone, welcome back to this channel. In this video, I'm going to walk through the setup needed for a noise figure measurements on a spectrum analyzer. So before we get into the spectrum analyzer, let's go through some of the options for noise source that we can use nowadays. So if you're coming from old school, you should see this before 346 model of noise source. The end of that character represent different type of model, the frequency coverage and whatnot. So this is a manual type noise source where you have to key in the noise ENR table into the spectrum analyzer before you can use it for calibrations or even for measurements. And it's using BNC to drive the on and off state. Most of the spectrum analyzer has this positive 28 volts at the rear of that machine. So the second options that you can use is this Smart Noise Source, SNS. So this is a N4000 series and number at the end is representing the band that is covering. Today we're going to use one of these for the calibrations and also measurement setup walkthrough. This noise source utilizes a special type cable. It's very similar to the power sensor type cable. So it's an 8-pin cable. It's connecting between this noise source and the spectrum analyzer at the rear of the spectrum analyzer. So I'm going to show you how it looks like and how the connection should look like. So the third options that you have is a USB type smart noise source. These two type has the ENR table installed in their own ROM. Means that once you connect it to a spectrum analyzer, it's able to read it through without having user to key in points by point. And this is using USB interface instead of the special 8-pin type cable. So we have this in the recent year and you can work it out whether you need this or you want to go back to the 346 model. So first of all, I'm going to show you how it looks like. So as you can see on the screen right now, I have the camera pointing at the smart noise source that I'm using. And this is a N4000 series smart noise source. As you can see at the back here, is a special rounded 8-pin type of connector. So easily you can just plug in and then just rotate it to find the guide pin. And then once you have that, just go in and tighten it. So let's look at the other side. So let's look at the rear of the spectrum analyzer and where to connect that. So this is the connector for the smart noise source. So you can see that this is an 8-pin type and you should connect this to there. So just rotate it and you should find a guide pin, and once you found that, just plug it in and tighten it. So for this exercise, I'm going to use a 10 dB pad for the measurements. So this is how it looks like. Let's preset everything. So by default, if you turn on a spectrum analyzer, the first screen that you're seeing is the spectrum analysis. So go to mode and look for noise figure. I haven't set out anything yet. So the first thing I want to do is to connect the cable from the spectrum analyzer directly to the noise source. So we expect to see a flat line here, but it's not because we haven't calibrated the system yet. So what I would recommend to do is to set the start-stop frequency. For this instance, we start with 1 gig, stop at 2 gig. You can change to any frequency that you want, it's fine. So, but for this exercise, this is what I'm going to do. As you can see here, cal stays uncal because we haven't run the calibrations yet. The third thing I want to do is to change the number of points. So for the benefits of this video, I'm going to set it to 51 points. So as you can see, when you increase the number of points, it takes a longer time to go through. You can try it to 101 points and you can see that the sweep time takes a bit longer than 11 points. So you increase the resolutions and you increase the sweep time. So let's change back to 51 points because I'm going to change another parameter. So the next thing I want to do is to change the resolution bandwidth. Currently we have 4 meg. It's wide open, there's a lot of noise coming in, a lot of fluctuations happening. So for calibration purpose, normally I'll go with something very narrow. Let's start with 100K. Even at 100K, you see that it takes a long time to sweep through because at every point it has to have the filter to stabilize and do the measurements. So while it's doing its thing, let's go to measurement setup. The next thing I want to do is to turn on the average. So for this exercise, I just turn on 5 so that you can get some idea of what's the effect to it. And I will turn on averaging. so that you take 5 measurements and get a good average result from that. As you can see, after all this setup, it does increase the sweep time by a lot. So this is the first thing I want to do before I run the calibrations. And one more thing to be aware of, once you have done the calibrations, this restart is very crucial, because when you have averaging on, the measurements will take the previous and the current and average out. And if happens that you have something change on the connections, the measurement is still ongoing and it does affect the end result. So this is where you need to restart the measurements again. So once we're happy with the setup, the start-stop frequency, the resolution bandwidth, the number of points, and we make sure that the noise source is shown here, the next thing we want to check is this. Make sure the ENR table is loaded. So we go to measure setup, go to ENR, and from here edit measure table. So you should get all the informations correctly from the noise source here. That's why we call it a smart noise source, because all the data is burned into the ROM of this noise source. As you can see, at every point you have the ENR value. You can change that, it's up to you, but you won't overwrite whatever in the ROM. So let's go back to close. Okay, once we're happy with all the setup, we can run calibrations. Calibration is as easy as plugging in the cable directly to the noise source without any device under test in the middle between the two. So you take some time, I'll come back after the calibration is done. So the calibration is done. It took about a good 20 minutes for that. And once the calibration is done, you can see the cal state has changed to green color. And the value of this is makes more sense right now. It should be about 0-ish. So let's pull that up to the, and yeah, you can see that the fluctuation is much lower if we change the parts per divisions to something bigger like 1 dB. So it's much better than previously before the calibrations happened. So let's go to sweep so that we can restart measurements. So it's pretty much around that area, which is fine. So I'm going to show you what do I mean by you have to restart the measurements right after you change the setup. So we have done the measurement here up front. Let it continue. While doing that, let's add in the device under test in between. So I've connected the device under test in between, and you're going to see the result right now. So the scanning is up to here around this area, and let's run for the second round, and you'll see that this reading initially is here. It will be elevated to about 5 dB. Because the first reading is about 0, this is 10 dB, noise figure at 10, 12 dB, and average is about 5 to 6, which is about that range. So you can see that the reading is not that great. It just gives you an average reading right now, and this is the part where we left the cable open before the connection was done, and let it run for a while. It should continue to go down, and right now if you turn on the marker, it will be way above the value. So marker is over here, so it's about 1.5 gig. It's infinity is a huge number, so it's not taking out anything. So this is the reason why you need to restart your measurements so that it tallies to the current setup. So in summary, do the setup, especially on the resolution bandwidth, reduce it, narrow it down to something that you can handle. Once you narrow it down, the sweep time will increase significantly. Then you set the number of points, you set the start-stop frequency, run the calibrations. It will take some time. Then before you put in any device on the test for measurements, just put a true connections and see whether the result makes sense before you proceed on with your device under test. So for this case, it's very straightforward because the device under test is an attenuator. It's roughly about 12 dB loss. So your noise figure should be about that range, 12. And if you have a LNA, it's a bit harder to gauge. So that's the reason why I'm using a pad instead of a LNA. Again, if you have a LNA, that's where you want to measure, put an LNA there and do the measurements right after the calibrations. I hope this helped. Thanks for watching.